Welcome my dear students, colleagues and subscribers of this channel. After discussing and analyzing analysis of one-way analysis of variance, it's time to discuss two-way analysis of variance. Before I do it, let me share with you that I'll be using this data set that is known as implied data set that I have downloaded from the net, and the total number of observations in this data set are 474, and this is implies data regarding their salary beginning, previous experience, and some other categorical variables. So I would like to see the impact of two categorical independent variables on the salary of the implies. So I'll do that in SPSS. So let me start with the introduction. The two-way analysis of variance is used to assess the effects of two independent categorical variables both alone and in combination with each other on a single continuous dependent variable. In this lecture, we will discuss how to perform and interpret the results of two-way ANOVA. I'll also explain how to select follow-up tests, whether these are appropriate. Let me also tell you that two-way analysis of variance has two categorical independent variables and tests three hypotheses. It tests the two main effects of each independent variable separately and also whether there is an interaction between them. Our data set contains the data on 475 implies, and the data set is known as imply data set. Our dependent variable is salary, that is a continuous variable. Our first independent variable is gender, which has two levels, that is male and female. Our second independent variable is job category, and it has three levels, that is clerical, custodial, and managerial. Since gender has two levels and job category has three levels, we have six groups of participants. The two-way analysis of variance allows us to evaluate three null hypotheses. The main effect for the first independent variable, that is gender, the null hypothesis is there is no difference between the mean salary of male and female implies. The main effect of the second independent variable, that is job category in this example, and the null hypothesis is there are no differences between the mean salary for implies of various categories. And then the third null hypothesis is about the interaction effect, that there is no interaction effect between gender and job category and implies mean salary. The final hypothesis or the last hypothesis tests whether the impact of one factor depends on the level of the other factor. For example, does the effect of gender on implies mean salary depend on their job category or not? So to do that, let me go to my data set, and here is my data set. This is a variable view, and this is the data view. So in order to perform two-way analysis of variance, I'll navigate to general linear models and then univariate analysis. In the dependent variable list, I'll put current salary, that is salary variable, and in the fixed factors here I will put gender as the first categorical variable and employment category as the second categorical variable. When I click on plot, I will use job category on horizontal axis and gender on the separate line, and then I'll estimate the combined effect of these two variables. Regarding the post-hoc analysis, I'll send job category, which has three levels, into the post-hoc test for this, and I'll click on two keys HSD test, and when I click on continue, after that I'll click on OK. So this gives me univariate analysis of variance. The first table shows that gender has two categories. Out of 474, 258 are male and 216 are female. Regarding job category or employment category, 363 belong to clerical jobs, 27 to custodial, and 84 to managerial jobs. So they are managers. This is the test of between subjects effects. Now in this table, uh, these three rows, that is gender, our first categorical variable, job category, our second categorical variable, and gender times job category, the interaction effect, these are of interest to us. So if we look at the f test of these three variables, that is the gender, the job category, and the interaction between gender and job, then the p value shows that these variables have highly statistically significant p value. So, as I mentioned, the three null hypotheses. So we reject the first null hypothesis based on f value of 59.359 associated with p value of 0.000, that there is no difference in the mean salary of male and female, but we reject this hypothesis. Similarly, regarding the job category based on F test score and associated p value, we also reject the null hypothesis of no difference between the mean salary of clerical, custodial, and manager categories. So we reject this null hypothesis. Similarly, there is a interaction effect between gender and job category because the p value is less than 0.05, and we can see the post hoc analysis of this. And regarding this, if we compare, here is the comparison of clerical and custodial, but there is no significant difference between the mean salary of clerical and custodial. So far as the mean salary of clerical and manager is concerned, there is a significant difference between these two. Similarly, regarding custodial and clerical, there is no significant difference between the mean salary, but regarding custodial and manager, there is a significant difference between the mean salary of the employees. So far as the manager and clerical salaries are concerned, there is a statistically significant difference between the mean salary of managers and clerical staff, and this is also true for the manager and custodial mean salary, because the p value for these two couple of variables is also statistically significant. We can also see at the homogeneous subsets. So far as clerical and custodial are concerned, there is no significant difference between the mean salary of clerical and custodial. But so far as the managers are concerned, their mean salary is significantly different than those of clerical and custodial. So this is the analysis of finance. Here is the mean salary plot, and along the horizontal axis we measure the mean salary of clerical, custodial, and managers, and here we have two categories of gender. This blue one is for male, and this green one is for female. So far as the mean salary of manager are concerned, for both male and female, they are greater than the other two categories. But the mean salary of male for manager is much higher than the mean salary of females. So the gender variable is significant, and the job category is significant, and the interaction between the two variables is also significant. So my dear students, this is how we can use two-way analysis to estimate the effect of two categorical variables on the comparison on the mean salary of various job categories and gender. Thanks for watching. You may share this with your students, colleagues, and various WhatsApp groups so that it could reach to the maximum possible number of people. Thanks.